Number 72, integrated concepts. In certain large geographic regions, the underlying rock is hot. Wells can be drilled and water circulated through the rock for heat transfer for the generation of electricity. Letter A, calculate the heat transfer that can be extracted by cooling 1 kilometer cubed of granite by 100 degrees Celsius. All right. So we're talking about heat transfer, and then we're talking about a certain temperature change, right, of heat transfer of an object. So we're talking about the change in heat of an object itself, and we're probably most likely dealing with then this formula over here. That tells us that the heat gained or lost by an object will be equal to the mass of the object times the specific heat of the object, multiplied then by the change in temperature of that object. So we know the change in temperature. They told us it was 100 degrees Celsius. And we're talking about granite, so the specific heat of granite, we looked that up. It's 840. Now, what's the mass of granite? Well, they told us the volume, but you know at this point, right? We can easily convert from volume to mass. We just have to know the density. All right, so why don't we, so realize that the density, I'll write it up here, the density is equal to the mass divided by the volume. And the mass then is equal to the density times the volume. So what I can do basically is just take this value and substitute it on in for m. Okay. So if we do that, it's the density of granite multiplied by the volume of the granite multiplied by the specific heat of the granite multiplied then by the change in temperature of the granite. Now the one thing is they told us it's 1 cubic kilometer, but you know you need, right, cubic meters in our equations, and therefore we're going to have to do that conversion. So 1 kilometer cubed, right, just kilometer on the bottom, meter on the top. 1,000 meters for every 1 kilometer, but that whole thing has to be cubed, right? So this is basically 1 cubic kilometer is then 1 times 10 to the 9 cubic meters. So this is the value you're going to be plugging into your formula. So let's do it. So Q is now equal to the density of granite, which was 2,700, gotten right from the text, multiplied by the volume, which is 1 times 10 to the 9 cubic meters. Specific heat is about 840, gotten from the text, and the change in temperature is about 100, as given in the problem. So let's do it. 2,700 multiplied by 1 times 10 to the 9 times an 840 times an 100. We get a tremendously large value, so we get 2.7 or so, 2.29, however you want to round it. Oh, no, excuse me, 2.27. 2.27 times 10 to the 17th, and that's in terms of joules. So that would be the amount of heat transfer that would be occurring. So letter B now. How long will this take if heat is transferred at a rate of 300 megawatts, assuming no heat transfers back into the 1, I guess they forgot the cube there, 1 cubic kilometer of rock by its surroundings. All right, so we've done this concept now for the past 2 problems. Right, so take a look. I'm just going to use the formula I developed there in the past 2 problems. So take a look where this comes from. Just view number 70 or 71. This is going to be equal to MC delta T all over then the time. I want to solve for the time, so therefore I can just do my little algebraic trick here. Just simply move them like so. And all we simply have to do now is just plug in, right? So we know the mass. Actually, yeah, do we know the mass? Yeah. We did, yeah, well, we didn't find the mass, but the mass. So basically all I need to do now is just take this result and actually, sorry, I'm just getting a little turned around. So all I really need to do now is this MC delta T is what I just calculated up here, right? Because this is MC delta T and I just did some conversions. So basically I'm just going to take that value, 2.27 times 10 to the 17th, and then divide it now by the power. But remember, this is in megawatts. We need it in just watts. So this is 300 times then 10 to the 6th, and that would be in terms of watts now. So let's just simply do that. So this is then going to be divided by 300 times 10 to the 6th. And that's about now 7.56 times 10 raised to the 3. It looks like 8, okay? And that is in terms of seconds. If you wanted to find that in minutes, right, just divide that by 60. So that's a big, large number. If you wanted to find hours, just divide it by 60, right? If you wanted to find days, divide it by 24. And then if you wanted to find years, divide it by 365. So it'd be about 24 years. okay, if you needed to do the conversions. All right, guys, thanks for tuning in. Please remember to help us out and subscribe, and we will see you soon. Take care.